Hi, my name is Mr. Peck from Ideas Inc. School, and today we will be discussing electricity part 3. In this chapter, we will be talking about the effects of electricity, the types of electrical hazards, and the safety precautions that we need to abide by. Let's begin by listing the 4 main effects of electricity. Electricity can cause a lighting effect, heating effect, magnetic effect, or a chemical effect. The lighting effect occurs when electrical energy is converted to light. This can happen in a tungsten light bulb. Tungsten is a metal with a very high resistance. As a result, when a current passes through the thin filament, electrical energy will be converted to heat. This heat causes the tungsten to glow, thus releasing light energy. Another use of electricity is its heating effect. An example of this is in an electric iron. Inside the iron is a heating coil made of nichrome. This is an alloy made of nickel and chromium. Due to the high resistance of this material, when a current passes through, electrical energy will be converted to heat. The next use of electricity is the ability to induce magnetism. By wrapping a wire around an iron nail, we can turn it into a solenoid. This solenoid uses electricity to induce a magnetic effect. A solenoid can be found in doorbells, alarms, and it is also used to lift heavy metallic objects in scrap yards. In order to increase the strength of the magnet, we can: Number 1. Increase the current by increasing the power supply. Number 2. Increase the number of coils wrapped around the nail. Or number 3. Replacing the nail with a material that is more easily magnetized, like a soft iron core. Lastly, we will discuss the chemical effect of electricity. Please pause the audio and refer to the electroplating diagram drawn in the notes. While doing electroplating, 3 conditions need to be satisfied. Number 1. The object that is to be plated must be connected to the negative terminal of the battery. This object will act as the cathode. Number 2. The material used for plating must be connected to the positive terminal of the battery. This material will act as the anode in this setup. Number 3. The electrolyte and the anode must contain the same metal. For example, if I want to plate my metal keychain with copper, I will have to attach the keychain to the negative terminal, and then attach a copper sheet to the positive terminal of the battery. Lastly, I have to make sure that the electrolyte is a solution containing copper ions. A good example will be copper sulfate solution. If the setup is done properly, the size of the anode will decrease over time and the keychain will be coated with a pinkish-brown metal. This is because the copper anode is chemically turning into copper ions, and these ions are attracted to the keychain at the cathode. Upon reaching the cathode, these ions will revert back to copper again, thus coating the surface of my keychain. We have reached the last part of the chapter. In this section, we will be discussing the 2 main types of electrical hazards and what precautions we should take to avoid them. The 2 main types of hazards are electrical fires and electric shocks. The first scenario involves old and frayed wires. This occurs when the insulating material surrounding the wire wears off. As a result, when 2 exposed wires touch, a short circuit will occur. A short circuit happens when an excessive amount of current flows through a wire or component. When that happens, a lot of electrical energy will be converted to heat, causing a fire. To prevent this from happening, always check the conditions of the wires, especially for appliances that have been in use for a long time. The second scenario involves damaged plugs or outlets. Due to age, the casings can become damaged. This can expose the wires within when they come loose. Thus, when a person accidentally touches the exposed wire, that person will suffer an electric shock. To prevent this from happening, always replace or repair damaged electrical plugs and outlets by a qualified electrician before use. When attempting to repair faulty appliances or electrical wiring, boots with thick rubber soles should be worn to prevent the current from flowing through the body to the ground. You can also stand on thick rubber mats while doing the repairs to prevent electric shocks from happening. The third scenario involves overloaded outlets. This occurs when many appliances are plugged into the same socket. When that happens, a large current will be drawn from the power outlet. As a result, a lot of electrical energy will be converted to heat, causing a fire. To prevent this from happening, do not overload a single power outlet. Spread out the plugs over multiple outlets instead. And the last scenario involves wet hands. Moisture lowers the body's resistance, therefore making it more likely for current to flow through the body to the ground, causing an electric shock. Thus, the rule of thumb is to never touch any electrical appliances and outlets with wet hands, and never be silly enough to hide under a tree or run across an open field during a thunderstorm. We have come to the end of electricity part 3. If you have any doubts, please approach Mr. Peck. Thank you for listening and have a nice day.